Okay, for those of you that want to get a little more practice with Punnett square single trait crosses, this is what this is all about right now. So I'm going to go through a demonstration, and then I'm going to give you some time to practice it on your own for the next three. So for our first cross, we're going to focus on the seed shape of Mendel's peas. Round is dominant, and wrinkled is recessive. So we have a capital letter for the dominant round. We have a lowercase letter for the recessive wrinkled. So let's complete the following cross that you see here. We're going to cross an individual that is homozygous dominant with one that is heterozygous. Step one, we're going to take the alleles from parent one, who is homozygous dominant, and we're going to split them and place the alleles on the top of the square. So here is the first one, here is the second one. Ultimately, this follows Mendel's law of segregation, which is to segregate the alleles, or separate them. So there's the first allele, here is the second allele. For the second parent, you're going to do the same thing, but these alleles will go on the side of the square. So the capital R here will go in this location, the lowercase r will go in this location. Once again, that segregates the allele, following Mendel's law of segregation. At that point, you have your Punnett square set up and you're ready to start making your cross. So let's move these out of the way before we do so. Just like your multiplication tables, when you're in grammar school, you take this allele, cross it with this allele to get to homozygous recessive or dominants. This cross with this, same thing. This cross with this, and this allele cross with this allele gives this. Typically when you take the STAR test, you're going to end up having some question that you have to answer associated with the Punnett square. And this one I said, what % of the offspring are predicted to have round seeds? I recommend, to prevent yourself from making mistakes, that you highlight all of them in the Punnett square that have what we're looking for. So I asked for round. Once again, don't forget, if you look at the top, round is dominant. So if it has a capital letter, it has to be a round shape. So our first individual, our second has a capital R, the third has a capital R, and the fourth. Therefore, your final answer for this one should be 100%. 100% of them. So now I want to give you a chance to try to solve the next Punnett square. Let's move forward. And you are going to use the same trait, which is round versus wrinkled, dominant versus recessive. I've given you the letters. And I want you to cross a heterozygous individual with a homozygous recessive. I'm going to give you 1 minute to do that. First thing you need to do is identify the parent genotypes, split them on the Punnett square, and then complete your cross. I will show you the question as soon as the 1 minute is up. So you may begin now. Okay, so if you were to solve this one correctly, you should have picked for the heterozygous parent a capital and lowercase. For the homozygous recessive parent, don't forget recessive means lowercase, you should have picked 2 lowercase r's. If we go to split parent 1's alleles, let's go with our highlighter. I'll stick with the yellow. The capital R will go on the side. The lowercase r will, or excuse me, over the top. I always put that one on top. So there's our capital, there's our lowercase. And then if we split the two lowercase r's, you will find each on the side. If you complete the cross, if you did so successfully, big R, little r, this times this gives us two small r's. This times this is a big R, small r. This and this is a little r, little r. Your question to answer, take a moment. What percent of the offspring are predicted to have wrinkle seeds? We'll give you about 5 minutes to, or 5 seconds to highlight your answers or circle them. Okay, let's see how you did. Wrinkled, of course, is the recessive trait. So in order to get the recessive trait, you have to have the homozygous recessive, just like this second parent. So how many in this chart or table have the two lowercase r's? Here and here. So if you put 50% as your answer, you have the correct answer. Let's try another one. This time you are going to cross a short, we're going to switch the trait to tall versus short, so plant height. You're going to cross a short individual with a homozygous recessive. Be careful, this one's a little trickster. I'm hoping you're becoming better at this, so we're going to give you 45 seconds to complete this one. You may begin. We're going to go back to our original. Well, that's unfortunate. Nope. And there's the timer. So if you solve this one correctly, you should have had, for your short genotype, two small t's. And here's the trick. Homozygous recessive is another word for short. You can only receive a short individual if you have two lowercase t's, which is described as homozygous recessive. If you split this parent, here's our little t on top, and there's a second little t. Splitting this parent, here's the first little t, the second. By the time it's all said and done, I'm hoping you can see it already, you're going to have nothing but homozygous recessive offspring. So if you answer the following question, what percent of the offspring are predicted tall? Somewhat of another trick question. In order to receive tall, what kind of letter do you have to have? At least a big T. So if you put for this answer a 0%, you are correct. Let's try the final practice problem. This time you're going to cross, using the same trait, plant height, a homozygous tall, with a short individual. We will give you 40 seconds on this one, maybe a bit longer. I'm going to start the music first this time, so go ahead and try to solve it now. Okay, so let's see if you were able to complete it correctly. So homozygous tall, dominant is tall, two capital T's. Homo, of course, prefix homo means the same. Short is the recessive form of the trait. In order to get the recessive short, you must have the homozygous recessive form. If we split the alleles of parent 1, capital T, split the alleles of parent 2, there's our lowercase t and lowercase t. And finally, when you complete the cross, what do you notice about these individuals? Take a moment to answer this question. We'll give you about 10 seconds to do so. So we've practiced the wording on each of these, but how do you describe an individual with a capital and a lowercase? I am hoping you came up with heterozygous, because that is what this individual is. All four of them, I should say. Guaranteed that every individual, every bit of offspring in this kit cross will be a heterozygote. Why is this the case? Somewhere in your explanation, you should identify that the prefix hetero means different, and the big T and little t are different types of letters. So I hope this helps you to understand Punnett squares. If you have any questions, feel free to stop by and ask at any time. Have a good one.